Good morning, everybody. Welcome to a rainy, cloudy, but wonderful morning of Chem 1105 with your host, Dr. White. Do you notice my fingers cause my eyes to open up? But anyways, good morning. Uh, Here's today's game plan. One, I have some announcements. Then I will go through my world famous review for the next test, which is test number one. Then we'll have our lab and you'll get out early. But in real life, if we were face to face, I'd do the same thing and you'd also get out early because I know how to teach lab. Modest, aren't I? All right, important announcements. One, hopefully got the email about my office hours. And next day or so, I'm going to put out an email about what you would think of the times listed in that email would be good office hours for me to help you. In other words, where you could attend if you needed to. Next, this Thursday from roughly 10 to 11:30, I will at about quarter to 10, 10 o'clock, right after we do our lab on Thursday, I will send out the email with the password for test number one. Sometime tomorrow afternoon, I will post in Blackboard test number one in the assignment area. There's going to be two versions. I forgot what I call them, A or B or X and Y or Z2 and Y25, whatever. But anyways, download both of them. I also have in there the files, how to make a PDF file with your cell phone if you don't know how to do that already. And they'll be password protected. I'll send half the class one password, half the class the other. The tests are almost identical, but they're a little different. That's just how I do it, cut down cheating. And you'll have from 10 until 11:30, roughly, on Thursday. Take test number one, scan it or take a picture and upload it as a PDF file, unless you've gotten prior permission from me to be late. And you have to get that from me, and I respond with an email. Speaking about responding with an email, if you have gotten a letter, and this keep private, don't raise your hand or say anything like this, see me in private. But if you've gotten a letter from the Center of Access and Accountability, you should have forwarded it to me. And those who have, I sent an email about test number one if you have that letter. That's for special needs students. Again, don't say anything about it now. That's a private matter between you, me, and special needs students. And I fully support the center and always have fully supported special needs students. And with that, don't forget, make sure you have a calculator, this one or another scientific. If you forgot, go back and look at the video. I think it was last either Tuesday or Thursday where I showed how to do this. Use it and use it with scientific notation. Don't forget, my office hours have been changed. Tomorrow, I'll have it at 5 to 6 p.m. If you have any last minute questions, again, blueberry tea from Republica Tea. Don't forget, come to my office hour tomorrow. All right, thumbs up, people. Do you see Chem 1105 test one review on your screen? Thank you. All right, what you see on your screen is available in the lecture folder of Blackboard, conveniently named Chem 1105 test number one review. All right, let's go through things you should know. We started out the semester, I talked about the four branches at chemistry: organic, physical, analytical, inorganic. And organic is the best, but I'm biased. I'm an organic chemist. You're welcome, Ray. All right, next I talked about matter. And you should know matter is anything that has space, occupies space, and has mass. or has mass and occupies space, which is just about everything you see except the light. And some things you don't see. When you feel the wind, that actually has mass and occupies space. Now, I asked you to learn only 37 chemical symbols of the elements. You should know, for example, the chemical symbol for oxygen is O. And you should know that the chemical or the element with the chemical symbol H is hydrogen. That's two of the 37. You should know the other 35 also. We talked about the states of matter, which you should know. Let me move this out of the way. Hold on. And those states are solid, liquid, gas. And you should know a solid has definite shape, definite volume. A liquid has indefinite shape, but definite volume. And finally, a gas has indefinite shape, indefinite volume. The three states of matter, solid, liquid, and gas. And you should know some examples, like my water is liquid, and my eraser is a solid, and gas, the air you're breathing now, is a gas. Next, I talked about the types of matter. There's two types, pure substance and a mixture. And a pure substance can be an element or a compound. Gold is a pure substance. And if you get it properly, water is a pure substance. Unless you have it contaminated, then it ain't. Oh, that's not good English, is not. And the other type of matter is a mixture. An example, if I take salt and mix it with water, that's a mixture. Now, there are two types of mixtures. One is homogeneous, the other is heterogeneous. Homogeneous is the same throughout. The air you're breathing is a homogeneous mixture. If you look in a fish tank and you see the coral and the sand at the bottom and the water and the fish too, that's a heterogeneous mixture. And oil vinaigrette dressing is heterogeneous. Hopefully your ketchup, which it is, or barbecue sauce, which I like better than ketchup, is homogeneous. It's the same throughout. Now, when we talk about matter, they're properties of matter. And two types is a physical property, something you observe, like what color is something, and a chemical property. A chemical property tells you the ability of something to change, react. An example of that would be, and do not try this at home, water does not burn. That's a chemical property. Paper does burn. And that's a chemical property. Now, when we talk about property and matter, we can talk about the changes in matter. And one is a physical change, and the other is a chemical change. Now, a physical change is one matter changes from one state of matter to another, goes from a solid to liquid, or liquid to gas, or vice versa. Well, I haven't said that all semester, vice versa. I usually do the joke vice versa. I did it. Awful joke. But anyways, example of a physical change, if you have ice cubes in an empty glass and you let it sit out in the room, guess what? It melts, becomes a liquid. All right, Disha, where can I find this? Which are you talking about, the review or chemical physical change definitions? The review is located in the, hold on, I'm going to do something I should have done before. And all questions are good questions, and thank you for your question. All right, Everybody see Blackboard on your screen? Thumbs up, people. Thank you. If you click on course information, then click on lectures. If you scroll down past the chapters, past the important information, you'll see, oh, look, Chem 1105, test number 1 review. I also have test 2, 3, 4, and all those. And I even have, for test number 4. And I thought I had the final here. Yes, I even have, I thought I had the final. If not, all those tests 1, 2, 3, and 4 will help you with the final. And notice while we're here, if you haven't looked at it, you should look at test number 1, important information. This is stuff you don't have to memorize, but you do have to know how to use. All right, does that answer your question? All right, we were talking about, you're welcome, Disha. Hopefully I'm pronouncing your name right. If not, please correct me. All right, now, example, like I said, of a physical change is when matter changes from one state of matter to the other, like ice cubes melting. Chemical change is when a substance changes from one material or element or compound to another one. An example of a chemical change would be when metal rusts, iron rust. It's undergoing a chemical change to make ferric oxide. And next time you have a candle burning, the wax is burning to make the flame, and that wax is undergoing a chemical change. Next, we talked about temperature scales, Fahrenheit, Celsius, and Kelvin. Degrees Fahrenheit, degrees Celsius, and Kelvin. And I showed you 3 formulas how to convert from one to another. And the first one is, if you have degrees C, use that formula 1.8 degrees C plus 32 to convert that into degrees Fahrenheit. If you have degrees Fahrenheit, you use the second formula to convert to degrees Celsius, and that is degrees Fahrenheit minus 32 divided by 1.8. Remember, in the first formula, you do the multiplication for the addition. In the second one, you do the subtraction before you do the division. In the first 2 formulas, 1.8 and 32 are exact numbers. The only thing that tells you significant figures of your answer is the degrees C or F you put in to that formula. And the final one is Kelvin equals degrees C plus 273, and 273 is an exact number also. And we went through this in a problem set. Next, I talked about scientific notation. Scientific notation is a number never less than 1, greater than 10 or greater, times 10 to the power n. And you move the decimal to the right of the first non-zero number. If the number is greater than 10 and is positive, number moves. If the number is less than 1 and is negative. You know something? I haven't shared fun with you yet, so let's have some fun. Convert the following to scientific notation. Oh, it's 2 for Tuesday. And do be also. You're being asked to convert A and B to scientific notation. And when you're done, give me a thumbs up. And for those of you who have your webcam on, which is, oh no, no one. Oh, come on, someone turn it on, make Dr. White happy. Mine's on. Boy, it's like pulling teeth. Ouch. All right, I'm going to assume everybody's done. If not, yell out. All right, let's do A. How do you convert it to scientific notation? If there was a decimal, it'd be here. Move it to the right of the first non-zero number. How many times? 1, 2, 3, 4, 5. So I moved it 5 times. Any zeros at the end when there's no decimal is dropped or are dropped. How many times did I move it? 5. This number is greater than 10. So it's 1.275 times 10 to the fifth. Now B is less than 1. And again, now we have a decimal and we'll move it to the right of the first non-zero number. Lead zeros are dropped. Zeros at the end of a number like this, you keep. So this would be 1.20. I moved it 1, oops, missed 1, 2, 3. Since it's less than 0, it's minus, so that'd be 1.20 times 10 to the minus third. And that's how you do it. Don't worry if your webcam's broken, but by the way, you can get really good webcams from app abt.com. The Logitech, which I'm using, cost me about $100 plus tax, and it was free shipping. It works real good. All right, next I talked about and taught you significant figures. I'll never ask you the rules, but you should know how to do that. All non-zero numbers are significant. Lead zeros are never significant. Confined zeros, zeros between non-zero numbers, are always significant. Trailing zeros and no decimal point are never significant. Trailing zeros and a decimal point are. And the question would be, how many significant figures in this number, in this number, this number, and let's do one more. And this number. I'm going to work you hard today. And the question is, how many significant figures are in those numbers? Have fun. Get to work. All right, I think everybody's done. Let's take a look. How many significant figures? All non-zero numbers are significant. So in A, these are significant. Is there decimal? No. So no decimal point trailing zeros are not. So this would have 3 significant figures. In B, yes, we have a decimal point, and we have zeros too. My mouth is getting ahead of my brain. That happens sometimes. All right, we have 1, 2, 3 non-zero numbers. Zeros at the end with a decimal point are significant. So it's 1, 2, 3, 4, 5 significant figures. Oh, we've got a decimal point and leaves zeros. They are not, but non-zero numbers are, so this would have only 1. And finally, D, non-zero numbers are always significant. There's no decimal point, but confined zeros, zeros between non-zero numbers are, and zeros at the end with no decimal point are not. So that'd be 1, 2, 3, 4, 5. And that's how you do significant figures. Next, how do you round off something? If the first digit to be deleted is 4 or less, drop it, and all following digits you drop or replace with zeros. The second part after or, I don't usually give that in tests. Oh no, I gave that away. Anyways, and if the first digit to be deleted is 5 or greater, drop it, and all following digits, and replace the 1 in front is increased by 1. For A, round off to, well, let's make it 4 significant figures. For B, round off to, well, back to my rut, 3 significant figures. Have fun. Your turn. Oh, somebody's already got one done. If you're done, give me a thumbs up. If your thumbs up button is broken, do something else. Turn on your, no, I don't know. All right, I see a bunch of thumbs up, so let's get to work. First one, round this off to 4 significant figures. Keep the first significant figure, second, third, fourth. I'm going to use that to round off. Is that 4 or less or 5 or higher? 5 or higher. I'll drop this since I'm past the decimal point, and the 1 in front, I'll increase by 1, and that would be the answer. Now B, round off to 3 significant figures. Keep the 2. Notice I have a decimal. Keep the 6, keep the 4. use this number to round off. Is that 4 or less? Yes. So I'm going to drop all these. This stays the same. So the answer here would be 2.64. Remember on test number 1 and 2, 3, 4 in the final, underneath your name, it will say, please use proper significant figures for all calculated answers. And if you don't, I take off a point. Even if you did it right, you still lose a point if it's not proper significant figures. Now, when it comes to multiplication division with significant figures, you get the same number of significant figures in your answer as the number that you multiplied or divided that has the fewest significant figures. Instant replay for multiplication and division in slow motion. You get the same number of significant figures in your answer as the number that you multiply or divide that has the fewest significant figures. And for addition, you get the same number of significant figures to the right of the decimal as the number you're adding that has the fewest significant figures to the right of the decimal. I don't do subtraction this semester. I think maybe once, but addition and multiplication and division, you should know. Hang on while I get my calculator out. My calculator gave me this answer. What would be the correct answer on a test using significant figures? Your turn. Everybody all done? I'll give you 8.76 seconds. 7.2, 8, 8.7, bonus time. Time's up. All right, the question is, what should the answer be considering significant figures? So you look at this number, it has 3 significant figures. Look at this number, all non-zero numbers are significant. This has 4 significant figures. Which is lower, 3 or 4? Time's up, hopefully you pick 3. So my answer should have 3 significant figures. Keep the 4, keep the 6, keep the 2. The one to round off is 3. Is that 4 or less or 5 or higher? And the answer is 4 or less. So I'm past the decimal, I drop that. And the answer would be 4.62. Don't forget 10 squared. This is never considered insignificant figures. And that's how you do it. And someone else got the same answer as me. I guess I did it right. Yay. Oh no, it's Sarcastic Tuesday. I don't think I've ever had a Sarcastic Tuesday. Yes, I have. All right, let's get back to our review. Remember, exact numbers don't play a role in determining significant figures. Next, I taught you about the periodic table. You should know which elements, the first column, except hydrogen, are the alkali metals. The alkaline earth metals are the second column on the periodic table. The halogens are the elements, the second column on the right, and the noble gases are the column all the way on the right. And if I ask on a test, give an example of an alkali metal, well, my favorite, well, two of them, potassium, actually all three, potassium, lithium, or sodium. And you should know, say sodium, chemical symbols, Na. And you should be able to do that for the rest of them. Know what elements are metals. Remember, metal can be shiny. It has luster, which you can shine it. It's malleable. You can make it real thin, but I won't ask that. But example of the metal, gold, silver, copper, a lot of things. Next, we talked about the atom. And the atom is the smallest particle of an element that has all the properties of an element. And a key thing I taught you was Dalton's gold foil experiment, or not Dalton, that's Dalton's, Dalton's atomic theory. I'm getting ahead of myself. And elements are made up of atoms. And the subatomic particles that make up an atom, you should know. Electrons, negative charge, protons, positive charge, neutrons, no charge. Instant replay, electrons, negative charge, protons, positive charge, neutrons, no charge. And here, all right, remember the center of an atom is called the nucleus. The center of an atom is called the nucleus. And Rutherford's gold foil experiments help clarify, explain the nucleus. And you should know that the nucleus contains only protons and neutrons. Nucleus contains only protons and neutrons. Now, the atomic number from the periodic table tells you the number of protons and the number of electrons, because all elements have a net zero charge. Therefore, the number of protons has to equal the number of electrons, which you find from the atomic number. Now, where are the electrons? They're in the shells and subshells. Why do I keep on thinking of Sally Sells, I can't even say it, seashells by the seashore? Say that fast, I can't. But anyways, electrons are in the shells and subshells. The electron shells are 1, 2, 3, and 4. And in shell 1, you have one subshell, shell 2, 2, 3, 3, 4, 4. And that table will be given to you. Now, for the subshells, S, P, D, and F, don't forget, 1 is lowest energy, 4 is the highest. As you go down the table, you go to higher energy shells. Now, subshells, there's S, P, D, and F, but can you keep a secret? You only have to know S and P for my class, because you're only going up to atomic number 12, which is magnesium. I made a mistake last week, so keep a secret. You only have to know S and P subshells. Remember, between you and me, secret. And the subshell S, you can put up to 2 electrons. Come on, black bar, go away. Thank you. And P, you can put up 6. And we do the electron configuration. And that's, I'll never ask you, but that's statement how many electrons an atom has in each of its subshell. Remember, hint, numbers, letters, and superscript numbers. And we went through that like yesterday, so I'm not going to do it again today. And the final thing is valence electrons. And valence electrons, you should know, are the outermost electrons of an element. Valence electrons, you should know, are the outermost electrons of an element. And how do you find that? You see the top of the periodic table. And you have maximum of 8 valence electrons. And let me open up a periodic table. And let me teach you something I haven't. Everybody's thumbs up, people. You see the periodic table and it's not straight across, it's up and down. When you open up the PDF file, if you're not printing this, you want to read it off your computer screen, hit Control, Shift, plus, and it rotates it 90 degrees. Hold on. To the right. And you can make it larger by using the controls like here. And if you look at, this is the periodic table you should be using. At the top of each column in red, also the Roman numeral, are the number of valence electrons. Nitrogen 5, chlorine 7, argon 8. And you should know that. And that's my review for test number 1. Now, I'm not going to change the question because it takes too much time, but I'm going to put out a poll right now and let me know, yes, you liked the review and like another one for test 2. No, you didn't like it. And it looks like everybody likes to review. And now you know why it's a world famous review from me, Dr. White. Good news for test number 2, 3, 4, and the final, I'll do reviews. For the final, I'll spend about 4 hours reviewing in lecture. Yep, that's when my students do good on finals because they have at least 4 hours studying review with Dr. White. And you don't have a choice, it's in the syllabus. But anyways, I should cut that out of the video, I won't. If I look at the clock, I'll give you an extra break. This would be a good time to take a break and come back at 9:50 and we'll do the lab. So with that, I'll see you in about 5-6 minutes, 9:50. And with that, I'm gonna go stretch. time to get going. I was looking outside my weather window, and it's raining where I live in the Schaumburg area, and which is a good thing. If you look at my lawn, my neighbor's lawn, with all the rain we've been getting, it looks a lot better. So do my bushes. Ooh, thundering. I haven't, over the weekend, for the first time in a long time, I heard thunder. By the way, your instructor is a member of the official Lightning Watchers and Friends of Thor Society. I just made that up. I love looking at lightning. It's amazing. All right. It's time for, yeah, it's right. We didn't get that bad weather over the weekend where I live farther north of Glen Ellen, much farther. But anyways, it's time for lab. And today's lab, we'll be using Beyond Lab Z plus the internet. Now, what's today's lab? Well, let's find out. I'm just checking it. Today's lab, does everybody see detecting signs of a chemical change lab? Does everybody see that on your screen? Thumbs up, people. Okay, don't scare me like that. All right. How do you know when you mix two things together whether or not you have a chemical change? Well, chemical reactions when two or more substances are mixed together and new substance or substances are formed. How can you tell a chemical reaction has occurred? Simple. You see one of the following four signs in the mixture of the substances. And those four signs are conveniently located in bold. One, you see a major color change that goes from red to blue or clear to red or any other color from clear. The other thing you can see is if you see gas form. How do you know gases form? Bubbles are formed. By the way, I.E is shorthand for, I forgot what it is in Latin, that is. Bubbles are formed. A third thing is a precipitate is formed. What's a precipitate? That means you see a new solid. Jada, I'm going to show you where it is in Beyond Lab Z. Hang in there. Trust me, I'm a chemist. That work? How about trust me, I'm a doctor? Did that work? I'm both. All right. And so the third way of telling if you have a chemical change is when a precipitate is formed, which means you see a solid. As I mentioned yesterday, my sisters had those globes, paperweights with the snowman in it. When you shook it up, you saw the white snow come down. How do you like this? Hold on. It's time for a totally obnoxious demonstration. You see the white snow come down. And for chemists, I'd say, oh, look at the precipitate in there. It's snow, fake snow, but I'd call it precipitate. And when it rains and snows, they call it precipitation. Ooh, I didn't know chemistry got into the weather. And the final thing, sign of a chemical change, is if you see a temperature change. What does that mean? When you mix two things together, if it gets hot or if it gets cold, you have had a chemical change. And today's lab, it's a fun lab. You will determine if a chemical reaction occurs when you mix two substances together. Now, for mixtures 1 through 5, you'll look at the YouTube videos and record your observation in table 1. And here's mixtures 1 through 5. And if we look at the bottom, number 1 is for number 1. And let's look at this one. Let's have some fun. So. Oops, that's not what I wanted to do. All right, let's move this up here. Let's go to full screen. Everybody see YouTube now? Soda and vinegar. You don't have to put the food color in. Oh, look. See the foam? And you saw a foam, and foam is really just bubbles all together. And when you mix the vinegar with the sodium bicarbonate, was there a chemical change? No. Yes. So you now know the first answer on the first table. Everybody should get that right. Now, the first 1 through 5, look at the YouTube videos at the bottom. 6 through 7, we're going to go to Beyond Lab Z. Now, I have in here how to do it, the procedure, but I'm going to show you. We're going to log in, click chemistry, click inorganic. Now, does everybody see the Google Dragon on there? Hold on, I got to open this up. All right, now let's go to Beyond Lab Z. I'm going to log in. Click on connect. And I'll open the link. All right, everybody see chemistry, organic chemistry, biology, and physics on your screen? Thumbs up, people. All right. Notice in chemistry, you have higher ed and high school. You want the higher ed box to be highlighted and click on chemistry, open. Now you'll see this screen. Does everybody see at the top titrations, calorimetry, inorganic gases, and so on? Thank you. Click on organic. Click on organic. Everybody see the lab where it says pH key and odor key? Thank you. Now, here's how you do the lab. And this is going to be a lot of fun. You take a test tube. Now, you can either pick it up or double click on where it says test tubes, left click. And notice there's a test tube over here in the test tube holder. That's what this is. And over here is a better shot of what it looks like. Now, let's say we want to do silver. I'll do this, and I click on the silver. Now, let's say I want to put in sodium chloride with the silver. I'll click over in this bottle and look what happened. The sodium chloride is clear, the silver is clear. Can everybody see the white solid in the test tube? Now you can stop here, but if you want to have some fun, right here is a centrifuge. If you click on that, it centrifuges it, which causes the solid to go to the bottom, and you see how the solid is formed. So when I reacted the silver chloride with the sodium chloride, was there a chemical reaction? And the answer is yes, there was. Now, when you're done, take the test tube, put it over this right here, and this time, and let go, and you're ready for the next one. Double click on the test tube. Oh, let's try ferric chloride. And let's try ammonia. Oh, did you see that? Was that fun? Did you see it went from light yellow? Is this light yellow? No, it's brown. Let's see if this precipitates out. It may not. It did. So was there a color change or a solid form? And the answer is yes. Was that a chemical change? And the answer is yes. And I have here how to do it if you didn't see it. Here are the steps. And your observation, you put down either color change or something like that. And then there are 14 of them. When you're done, guess what? I have some questions for you to do. And that's today's lab. Now remember, last Thursday's lab, I believe it was calorie of a nut, is due today. Make sure you get it in. Today's lab is due Thursday. Make sure you get it in. If you have any trouble with today's lab, come to my office hour tomorrow. I'll help. In case you don't know, I make a good lab partner. Even when we're face to face, I help out students when they're having trouble. Because lab is supposed to be fun. Any questions about the lab? Remember, there are 4 things. Oops, my finger's broken again. There's 4 things. Who wants to do that? There are 4 things that if you see, you've had a chemical reaction. And those are if you see a major color change, you've had a chemical reaction. If you see gas form, you have a chemical reaction. If you have a precipitate, a solid form, you have a chemical reaction. And if you have a temperature change. Now, unfortunately, right now, the Beyond Lab Z's, you won't see gas or temperature. But that's why I picked the other ones from the internet. And because I'm sneaky, one of those, maybe more, but at least one, the answer is no reaction. So with that, that's today's lab. If we were face to face, we actually do this lab as COD. I'd say, all right, everybody, put on your safety goggles, put on your gloves. Let's do it. Remember, all waste go into waste container, and I'll have a bottle out for that, not down the sink, and go do the lab. And most students would be done by about 10:30 or less, and we get out way early. Well, in this case, I'm not going to sit here while you do the Beyond Lab Z. I'm going to let you do it at your leisure. And with that, I'm done for today. You're welcome, Yakub. Did I pronounce it right this time? And yay. Oh, one thing. If I ever say your name wrong, make sure you correct me. I do sometimes get names wrong. Correct me. And with that, I can say, gang gesund, be healthy. Goodbye. And I'll stay